So today in this section, we are going to discuss about a timber column. Going to discuss about what is timber column and how can we design using Indian Standard Code without being late. I want to describe it. At first, I just want to show you the steps. These are very essential to design. It is not necessary to follow these steps, but it is better to use these steps. Only then we can design the system timber column. What things should be calculated first, and that value might be used in later. Value of something that is needed at first will be calculated. Okay, so before doing the design process, I would like to talk about the types of timber column. Okay, typically there are three types. Okay, the first one is a short column, and second one is intermediate column, whereas the last one is a long column. So here is the criteria, and on the basis of which we can categorize the types of timber column. Okay, so the criteria is S by D, where S is unsupported height of the column, whereas D is the least side dimension. Okay, this is the column, and this is the elevation of the column. And for example, let's assume that this is the plinth level, and this is the first level. Okay, and this is the beam, timber beam. Okay, this is the total height of the column. For example, it is L. And what is unsupported length? That is the length from the bottom of the beam to the top of the plinth level. Okay, or top of the story height or floor level, we can say. So this is the unsupported length. That means the length of the column which is not supported by beam, that is unsupported length. Okay, so this is the S. And the next one is D. D means least side dimension. That means if the cross section of the timber column is like this one, if it is square, then we know that the both sides are equal. So least or greatest as that is equal, we can the value is same, so it doesn't matter for square column. But if you choose rectangle column, at that time you have to take the least side dimension. This length is B and this length is D. That means you have to take the this side length while calculating the slenderness ratio. I think it's the slenderness ratio. S by D is slenderness ratio. S by D, or you can say unsupported length by least side dimension. So if you divide S by D, and if the value is less than 11, then it is called, then that column is called a short column. And if that value is greater than 11 but less than K8, K8 is another parameter, and we can calculate the value of K8 as well. And the equation is K8 equals to 0.702 square root of E by sigma CPU. Okay, so what is E here? Is the modulus of elasticity of material, that is wood. Okay, and its value depends on the type of woods. For example, its value may be different for different type of woods. For example, sharp, deodar, or manure. We can find out the properties of these woods in several courses, and we can use that value to calculate the value of K here. Whereas sigma Cp, okay, sigma Cp is the permissible compressive strength for that wood. Okay, without consideration of the length of the column. So that is typically for the not a permissible compressive strength for a member, but for a section, that is for a section. Okay, so we will discuss this value detail in the numerical program. So for now, it's just sigma simply means the permissible compressive strength of the wood member, okay, wood section. So after categorizing the K, okay, so and if the I forgot to say about the long column. So the long column is categorized when the S by D ratio is greater than K8. Okay, so here is the main formula for S by D. We know that what is S, what is D, and we can categorize the column depending upon the this ratio. So after calculating the value of S by D and categorizing the member of timber column, we can calculate the value of FC. But that is, FC means the compressive stress, permissible compressive stress of the column member. So we can calculate FC If the column is short column, sorry, then the FC is equal to FCP. But if the column is intermediate column, we have to modify the value of FCP by this modification factor, okay, where that is 1 minus 1 by 3 multiplied by S by D multiplied by 8 to the power 4. So this is for intermediate column. And for long column, if the column is long, then you can calculate the value of FC by using this equation, 0.329 multiplied by E and divided by the Salinas ratio of the column, that is S by D S by D square, okay, if it is a long column. So after computing the value of FC, we can directly use this equation, that is P means safe load, P equal to FC multiplied by area of the timber, okay, cross-section area of the timber. That means you already have the permissible stress of the column member, and you already have the size of the timber. Then you can calculate the design load, or what is the safe load of that timber member. So in this way, you can calculate, or you can design the timber column. So I think we are going to do one example. I will describe it. I have already written here the how we can design this column. So I will describe it, and I think it is easy, and might be for everyone, as this is the equation is simple, and thus we can put the value into equation, so that we can get the value of all required parameter, and we can design the timber column. Okay, before doing equation, you should always remember that you should calculate all these things in same unit. For example, if Newton mm, or you can calculate kg per cm or kilonewton per meter, the units should be same, so that you will get the value in that range. So the question is, okay, we have a timber column, and that is a solid. So the question has given some details here. B, that means a list dimension of the dimension of column section, and D is the depth of the section, where B is 250 mm and D is 300 mm. And H effective. H effective means effective height of the column, that is 4 meter, and we have E, that is modulus of elasticity, 1.2 multiplied by 10 to the power 5 kg per cm square. Yeah, we need to convert this value to Newton per mm square, because all we are using Newton mm unit for whole calculation. So we convert the value of E into Newton per meter square, and the value becomes 0.12 multiplied by 10 to the power 5. So another parameter is FCP. Sometimes FCP can be written as sigma CP. It's just notation that is related to stress. So the permissible compressive stress for a column section, that is 105 kg per cm squared, and which is also converted to Newton per meter square here, 10.5 Newton per meter square. So we have to find out what is the ship's load carrying capacity of that column member. Okay, one important thing I need to say that I find it is very necessary to know that there is a difference between the capacity of the column section and capacity of the column member, because we know that the capacity, permissible compression capacity of a section is same for the same wood, but the actual capacity of that column is totally depend on the length of the column, whether it is short column, long column, or intermediate column. Depending upon its category, the actual safe load carrying capacity of that particular member might be different. So you just need to calculate the exact safe load carrying capacity of that column. So we are just going to complete these questions. Okay, so the first of all, we have we have described in the process part that at first we just have to calculate the value of Salinas ratio, that is S by D. Okay, here S is the effective height. You can just put it here, unsupported height, or you can just assume that S effective is equal to unsupported height. So S, the value of S is 4000 mm, whereas D means least side of dimension, so that is 250. Calculate divided by 4000 divided by 250 is 16, so this is greater than 11. Okay, so The value is greater than 11. That means the column is not short column. So we have to check whether the column is intermediate column or long column. To check this, we need to find the value of ket. If the s by d ratio is greater than ket, then it is a long column. And if the s by d value is greater than 11 and within the value of ket, okay, that is a parameter, then it is intermediate column. So we just calculate the value of ket here, and we can say that the column is intermediate column, okay, because the value s by d ratio, which is 16, is between 11 and 8. So the column is intermediate column, and for intermediate column we have equation to find out the permissible capacity, permissible stress on column, that is fc. So fc should be modified, fc equal to fcp which is modified by this parameter, okay. So we have all formula, all values of this parameter which is used in this equation. So okay, we can calculate here all these things. So the value of fc is 9.776 newton per mm square. Okay, so we have the value of fc. As we have value of fc, now we can calculate the value of area, that is b multiplied by d. So we have fc and area, then we can calculate the safe area load. So hence safe load p can be calculated as fc multiplied by a. So we know the value of fc, that is 9.776, and we know the value of area. So if you look at here, we are using the same unit here, newton per mm square, and for area it is mm. So we get the value of safe load in newton, and then we divide it by 1000 to get the value in kilonewton. So the safe load capacity or safe load value of that particular column is 733.2 kilonewton. Okay, so in this way you can calculate the safe load capacity of the section. That is for rectangle or square column. And for circular column, there is no much different, just the way of calculating the area, required area, is different. So look at here, the question is almost the same. So we have, the only difference is the previously the column is square or rectangle, but this one is circular in cross section. So the diameter of circular column is 300 mm, and we have effective length, that is LE, is 6.5 meter, whereas sigma cp is 102 kg per cm square, and we have the value of modulus of elasticity of that wood is 1.2 multiplied by 10 power 5 kg per cm square. So we need to convert all this value which are in kg per cm square into newton per mm square, and we can easily convert this value. So we have all this, these are the given things in the question. So after rewriting all these things, now we need to calculate the value of equivalent length with square column. Okay, so just we need to convert the what would be the equivalent length if it was column, square column. Okay, so just we equate the area of the square and area of circle. So just d multiplied by d, pi by 4d squared. This is the area of the circle, and this is the area of the square, and we can calculate the value of the equivalent length if the column is square. So that is d equal to 265.8 mm. So we have already the value of effective length yearly, that is 6.5 meter, and we have value of d. So we can calculate the L by d or L by d ratio, that is 24.44, which is greater than 11. This is also greater than 11. Then we can sure that the column is not a short column. So we need to calculate the value of k, just in the similar way that we had already discussed about it in just a couple of minutes earlier. Okay, so just we calculate the value of k using that equation, and the value of k is 24.07. So okay, so the value of s by d ratio is 24.44, whereas the value of k is 24.07, which means column is long. So for long column, we have equation to calculate FC, that is 0.329 multiplied by A, and whole things is divided by slenderness ratio, square of slenderness ratio, that is S by dv square. So we can put all the values which are here to calculate the value of FC. So the value of FC is 6.609 milligram square. So like what we did in previous part, just we calculate FC, and if we multiply that FC by area of the column, then we can find out the safe load of the column number. So safe load is FC multiplied by A, that means area of the section, and we know all the values, so we can calculate the safe load, that is 467.162 kilonewton. Okay, so here is the equation again to find out whether the column is short, intermediate, or long column. We have already discussed all these things previous part, so I think we are going to skip it. So just you can read here what I have written here. Just you will understand what is the equation and how can you do it. So the process is just like you have to find out at first whether the column is short, intermediate, or long. After finding out the type of column, you can use a respective equation to find the FC, and ultimately you can find out the safe load of that member by multiplying FC by area of the timber section. So just there is one difference while calculating the safe load. Just in circular column, you just need to find out the effective length, equivalent length of the section. If the section is square, then you can use the same equation which is used for a rectangular square column. Okay, so this is maybe easy because we do not need to remember a large equation, and the concept is, I think, quite relatively easy in comparison to other questions. So you can calculate the value of FC, or you can design the column, or you can just analyze the column whether the column is sufficient to sustain the load or not. Or sometimes you need to just to write the steps how to design a column, timber column. So in that case, just write the steps only. Just you can assume B and D, and then you can find out the S by D ratio, and after calculating S by D ratio, then you have to figure out whether the column is short, intermediate, or long column, as we discussed earlier. And then finally you multiply that FC value by area of the cross section of that column to get the safe load of the column member. Okay, so in this way you can just design a column, timber column.